Hi and hello. Welcome to the Moodle session. Now, the diagram that we see is the topic what you're going to study today. Yes, is the moisture content. Moisture refers to the presence of liquid substances in the environment in the form of the state of a. Now, moving on to the moisture in solids, the first one we are going to see is about the nuclear moisture gauge. Yes, the diagram which is given over here is a real-time application-oriented diagram which is used in a day-to-day industry. Nuclear moisture density gauges have been in use for over 30 years. They offer the user a quick and accurate means of determining density and moisture content of solids, asphalt, rooftops, and concrete. Okay, here we have the diagram showing your nuclear moisture gauge. In this, we have a conveyor belt. This conveyor belt helps the material to move forward. See, the flow is in your right side direction. Now that is how your material moves. And with the help of this nuclear moisture gauge, you can measure both moisture as well as density. In order to measure your moisture, we need your fast neutron source. In order to measure your density, we need to have a gamma ray detector. Now, whenever you have to understand and separate the moisture, we use your fast neutron source to detect it. And to find out the density of the material, here the gamma ray detector sends the light with the help of source, and that again gets reflected. So the measurement from here moving on to your detector tells you what is going to be the density. So with this measurements, if we want to record it for further calculations, we have a cable to measure and it goes to your recording instruments. The next type is infrared of reflection moisture gauge. Now this is the diagram which tells you about the infrared moisture gauge, where can you see this? This diagram does not get support of any material, but it stands by its own, and the infrared flows into the material which moves on a conveyor belt, and this is what is going to be measured. The benefits of using this particular infrared is that you have an instant measurement both online, handheld and desktop instruments. It is non-contact, handheld and online models, and no contamination possible. It is non-destructive. All model samples can be used for additional assays. Moisture meter can be used for both liquids as well as solids. Now this is supposed to be the diagram, or you can also say that setup of an infrared reflection moisture gauge. Now here again you have a light source hitting the mirror and falling it into an filter. The filter filters the rays and that moves on to another mirror which is placed just where the sample, and that is viewed with the help of photocell, and an electrical output is given to a measuring circuit. So this is how you measure your infrared reflection moisture gauge. Yes, now it's the installation of IR moisture analyzers. Now as you saw in the previous diagram, you had a conveyor belt where you have the material moving onto it and leaving certain height. See here, this is supposed to be the infrared material or the instrument which finds out what is the moisture present in the material which is sent by your conveyor belt, and you have cables to record again. The next is microwave solid moisture analyzer. Here, as you all have oven in your homes, this is supposed to be a similar type. In a normal oven, you keep it, you heat it. Now the same thing is going to be followed here. It is used to measure water contents in plastic powders, chips or pellets, soaps, grains, powdered lay, plastic products, etc. For example, if you're going to use for chips, soaps and grains, it is not possible to move them in an open conveyor belt. So we need a closed circuit. Hence we chose your microwave to measure the solid. You keep it here, you close it and you measure it. This is the setup which is given. See here, this is going to be the moisture sensor where you're going to keep your material, and inside your oven you'll be having a belt which helps the materials to rotate and move, and that is viewed with the help of a computer. The next is capacitance moisture gauge. This is how a capacitance moisture gauge is going to look, and always or mostly this capacitance moisture gauge, see, this portion is inserted into a soil to find out the moisture in your soil. So the capacitance moisture gauge is mostly used to measure moisture in your soil. Now this is how the setup is going to look, and this is the diagram what you'll have to draw it for your exams. Now you have a plastic insulator, you have a capacitor electrodes and an electrical signal to read out at the yes. The next type of gauge measurement is conductance moisture gauge, and this is how a real-time conductance moisture gauge is going to look. Okay. Now this is a moisture measuring cell for granular materials. Now as I've told you, this is the portion where previously you saw it as a wall, and you have an insulator and an electrodes, and a sample is fed into it. With the help of piston, if you're going to press it towards your wall, the way you push it or the force that you're going to give, it goes to your bridge circuit. For example, if your bridge is not balanced, we say that the moisture content is correct. If there is going to be an unbalanced condition, then the moisture is not maintained properly. The next diagram tells you about the moisture measuring probe. Now these are the heads which will penetrate into the materials to find out the moisture. Now this diagram tells or gives the relationship between your moisture and your electrical resistance. As moisture increases, the percentage of moisture increases, your resistance decreases. With this, we come to the end of your moisture measurement. Now, as you have studied your moisture measurement and your humidity previously, you will have a small assignment to continue. So with this assignment, we will conclude this particular unit. You also have a small quiz to take, which will be very useful and helpful too for your exams. So kindly make use of it. For any queries, do contact me. Thank you.